Hello students and welcome to the automobile engine class. Myself Shanko Ghosh, assistant professor of automobile engineering department at Dr. Sudhi Chandrasu Degree Engineering College under the GIS group. Few of last classes we uh, describe here the module number 5A on the topic on the basis of fuel fed system in the petrol engine. So here for the fuel fed system we already covered few parts. On the first part we describe about the introduction of the fuel fed system, then we classify the fuel fed system, then its function and study the layout of the fuel fed system in the petrol engine. Then in the second part we discuss about the various components of the fuel fed system, and on the third part we continue this rest of the fuel fed component of the fuel fed system, as well as we also describe about the air cleaner. And the fourth part where we discuss about the carburetor, and the fifth part we discuss about the operations and the classification of the carburetor. Now in this sixth part which I told in, which I taught here today, that is only based on the various circuits of the different carburetor and the air fuel mixture. So students, let's start the sixth part of the module number 5A, which covered the topic that is fuel fed system in the petrol engine. So in the carburetor circuit, where a vehicle basically is driven in a different condition, so for the carburetor must supply, so for that reason the carburetor must supply suitable air and fuel mixture during all the condition of the driving. So in order to provide this different mixture, a carburetor is provided with a different circuit for its proper operation. Here we study about three of these circuits, where those are choke circuits, ideal circuit and the accelerating circuit. So here is the picture of this choke circuit. The choke circuit is the major circuit of the carburetor. When the engine is cold, a rich mixture is required. To start it. As discussed earlier, the choke circuit consists of a choke valve, which is placed in a air horn of the carburetor above the venturi. So basically here the choke circuit consists a choke valve. So this choke valve, which is placed in the air horn of the carburetor above the venturi. The choke valve is a simple kind of a butterfly which is operate either mechanical or the automatical. When we are talking about the mechanically operated choke system, the choke valve which is open and closed, by means of a cable and the lever mechanism, which is operated through a knob which is placed at the instrumental panel. When the knob is pulled up, the choke valve is closed. When the knob is pulled up, and valve is closed. Through there, it restricts the airflow. It restricts the airflow to the venturi, and greater pressure difference which is caused in between the inside and the outside of the carburetor. The greater pressure difference causes the greater vacuum. The greater pressure difference causes the greater vacuum inside the mixing chamber, due to which more fuel flow out of the main nozzle, which is resulting in rich mixture. When the knob, when the choke knob is pushed down, when the choke knob is pushed down, the choke valve is open. So it may be note that if the driver forgot to push back the choke knob, the carburetor will continue to supply. The carburetor will continue to supply a very rich kind of mixture to the engine. The excessive rich mixture will causes the poor the engine performance, and it leads to carbon deposit, inside the combustion chamber. In order to prevent this problem, the vehicle now provide the automatic kinds of choke. So to provide this kinds of problem, the automatic chokes are available. In an automatically operated choke system, the choke valve is connected to the thermostatic device that senses the temperature. Here the thermostatic device is closed, the choke valve, when the engine is cold and opens it, when the engine is cold and opens it when the engine is warmed up. The device generally consists of thermostatic spring, which is located on the exhaust manifold, which is actually a bimetallic strip. That means it's two different metal strips are welded together. And formed into a spiral, and a vacuum piston or a diaphragm. Both of these components are linked. So both of these components are linked with the choke valve. It may be noted that in a bimetallic strip, due to the difference in expansion rate of two metal, the spring tends to wind or unwind with the changing temperature. And it also a first ideal cam which is provided to maintain a small throttle opening when the engine is in cold position. So when the engine is in cold, the spring is moved up and keeps the choke valve in a closed position. In this position, in the closing position, the ideal cam keeps the throttle valve from the fully closing, and this causes the engine suction to draw the additional fuel from the main nozzle and also from the ideal system. So as the engine is started, the movement of the air through the air horn, causes the choke valve to open slightly, and also manifold and also the induction manifold vacuum acts upon the piston, which is pulled outward to open the choke valve further. The choke valve may remain in the position and until the engine is warmed up. Once the engine is started, the exhaust gas passes over the spring and it's warm up, and the warming of the spring unwinds it, which result the choke valve to start and opening. And when the operating temperature is reached, the thermostatic spring unwind enough to keep the choke valve fully open. And when the engine is switched off and cools down, the thermostatic valve spring again winds up and to close the choke. So these are the basic circuits operations of the during the choke carburetor circuit. Now coming to the another choke circuit, which is known as the ideal carburetor circuit. When the engine is in ideal condition, the throttle the throttle valve is almost the throttle valve is almost completely closed. In this case, there is very little air. In this case, very little air flowing through the venturi. Very little air flowing through the venturi, and there is no venturi effect. There is no venturi effect to draw the fuel from the main, and there is the no venturi effect to draw fuel from the main fuel nozzle. Thus, the main circuit cannot be used to supply the fuel. For this reason, the ideal circuit is required to supply the air fuel mixture just below the throttle valve, or otherwise the engine would stop. There is a small hole which is pivoted the upper part. There is a small hole which is pivoted the upper part of the mixing chamber, which is basically placed above the venturi. Here the air from the air horn centers into this small hole and is directed through the bypass passages. Then a separate passage, which is sometimes called as an ideal passages, which is providing alongside of this float chamber, which contain a slow running jet, and it is connected with a float chamber. So the fuel particles are swept into the bypass passage by the ongoing air, and then the air and fuel mixtures from the bypass passages goes to the ideal port from where it is drawn into the intake manifold. So this is because that there is no vacuum above the throttle valve, but a strong vacuum exists below it. Here an ideal mixture adjusting the screw, which is provided into a ideal port, which regulate the amount of air and fuel mixture that can be drawn into the intake manifold. The tip of the screw is tapered so that the air and fuel mixture is reduced when the screw is turned clockwise. Each screw can be set so to suit the individual engines. The ideal mixture adjusting screw is set at the factory itself, and sometimes of the carburetors have a tamper-proof cap on the screw to prevent the chances to the setting. So students, here is the pictures of the ideal carburetor circuit. This one is the float chamber. This is the air horn side where the air is entered in this area, and here is mixed with this air is mixed with the fuel, and then it goes to the intake manifold or to the cylinder. Now coming to the next slide, here we discuss about the another kinds of carburetor circuit, which is called or which is known as accelerating carburetor circuit. So in this accelerating circuit, which is provides basically the rich mixture, that means the extra fuel is provided here for the acceleration. When the driver wants to accelerate quickly, where driver wants to accelerate quickly to overtake the another vehicle, when the accelerator pedal is pressed down suddenly, accelerator pedal is pressed suddenly, the amount of airflow increased immediately. So but since the fuel has the higher specific gravity, so therefore a brief internal is required is required before the fuel gain speed and it maintains the desired balance of fuel and air. So therefore the air and fuel ratio becomes temporarily lean at the time when a richer mixture is actually required for the more power. So to overcome this situation, the acceleration pump is then provided in the system to momentarily supply the additional fuel until the flow from the main fuel nozzle increases. The acceleration pump is operated by the mechanical linkage contact to the throttle. When the throttle is suddenly opened, when the throttle is suddenly opened by the mechanical linkage, it forced the acceleration pump, and spring loaded plunger or the diaphragm to move the downwards and and the additional fuel in the pump chamber and the additional fuel in the pump chamber below the plunger is supplied below the plunger is supplied below the plunger is supplied from a small nozzle through the outlet check valve into the air stream of the carburetor. The, the, the circuit, this kind of circuit cannot discharge the fuel. This circuit cannot discharge the fuel again until the driver lets off the accelerated pedal. So students, here you can see in this picture, this is the picture of accelerating carburetor circuit. Here is an anti-pullover passages there. This one is the pump jet and the housing assembly. This one is the discharge neck check needle. This one is the throttle connected rod. Here is the inlet check valve. Here is the vapor vent. This one is the pump reservoir. Here is the pump piston spring and this is the accelerated pump rod. So here through this circuit this is a circuit is basically used for when we are required to speed up the vehicle during the acceleration. So students, here we discussed about the three types of carburetor circuit. Now we discuss about the air and fuel ratio. When we are talking about the air and fuel ratio, then you can understand the mixture of air and fuel which is entered into the combustion chamber during the suction stroke in the SI engine. So basically this air and fuel ratio is defined as the ratio at which petrol and air are mixed. In generally, it is expressed in terms of weight. Generally, it is expressed in the terms of the weight. The air and fuel ratio is necessarily to maintain. The air and fuel ratio is necessarily maintain the proper combustion and it varies with the engine speed. Theoretically, to complete 1 gram of petrol, to complete 1 gram of petrol, 1 gram of petrol, to burn 1 gram of petrol, we required 14.6 gram of air. So theoretically, when to burn theoretically to burn the 1 gram of petrol, completely burn of 1 gram of petrol, we require the 14.7 gram of air. So that's why this 14.7 is to 1. That's why this 14.7 is to 1 is called a stoichiometric air and fuel, stoichiometric air fuel ratio. The fuel can be burned into the combustion chamber even if the air fuel ratio is somewhat greater or the lower than the compression ratio. But if the mixture ratio is exceeds a certain limit, the combustion is no longer possible. So that's why this limit is now called as the limit of the inflammability, which is considered the range of which combustion take place. So basically for the petrol, the range of inflammability special varies the 9 to 20 parts of air to part of petrol. So this in exact air, enough air, when is so if the exact enough air is provided to complete the burn all the fuel, the ratio is known as the stoichiometric ratio, and this is abbreviation is the stoich. And when the ratio is lower than the stoichiometric ratio, if the ratio is lower the ratio, the air and fuel ratio is lower than the stoichiometric ratio, then it is called as the rich mixture. If the air and fuel ratio is greater than the stoichiometric ratio, then it is called as a lean mixture. So some of the engines nowadays is designed to allow the lean burn mixture. So the basically students, you need to remember these things, that the 1 gram of petrol, the complete burn of the 1 gram of petrol, we require 14.7 gram of air. So here you can see in this picture, here is this showing the power and the air fuel ratio. So in this portion, which is the stoichiometric level is showing, this means the 14.7 is to 1. If the ratio is greater than the stoichiometric ratio, then it is called the rich mixture. And when the air fuel mixture is less than stoichiometric ratio, when the mixture air and fuel mixture ratio is less than the stoichiometric ratio, then it is called the rich mixture. When the air and fuel mixture is greater than the stoichiometric ratio, then it is called the lean mixture. So this equation where the gasoline fuel, the stoichiometric air fuel ratio is 41.7, we find that from this oxidation equation. Here this is the equation, the 25 numbers of O2 and 2 numbers of C8H18 combines, and when it is burned, it provides 16 atoms of carbon dioxide and 18 units of hydrogen, H2 water vapor with some energy. So this is the basic chemical reaction of the air and after the air and fuel mixtures. So this is the basic concept of the air fuel mixture. So students, here in the sixth part of this air fuel ratio, we discuss here about the various kinds of circuit of the carburetor circuit and the air fuel ratio. Then air fuel ratio or the air fuel mixture. So from the next class we started discussion on a new topic. So still then, stay at home and stay safe. Thank you so much, students. Thank you.